Now I would like to introduce myself, Harinath M. I am studying first B.Tech in Srinivasa Ramanujan Institute of Technology from the Department of Computer Science Engineering. Today I am discussing about the subject of linear algebra and calculus from the topic of maximum and minimum. Now we try to understand the given question, that is find a point on the plane 3x plus 2y plus z minus 12 is equals to 0 which is nearest to the origin. Now we go for the solution. Let p of x comma y comma z be any point on the plane, that is 3x plus 2y plus z minus 12 equals to 0. Now the distance between the origin and the point px comma y comma z is OP is equals to root of x square plus y square plus z square. Now we squaring on both sides, then we get OP square is equals to x square plus y square plus z square. Now let function f of x comma y comma z is equals to x square plus y square plus z square, let it be equation 1. And pi of x comma y comma z is, that implies 3x plus 2y plus z minus 12 is equals to 0, let it be equation 2. From Lagrange's functions, now we write the formula of Lagrange's functions. First, f of x comma y comma z is equals to function f of x comma y comma z plus lambda into phi of x comma y comma z, let it be equation A. Now we substitute equation 1 and equation 2 from above equation. Now we get f of x comma y comma z is equals to function x square plus y square plus z square plus lambda into plane, that is 3x plus 2y plus z minus 12. Now by Lagrange's method of undetermined multipliers, we find that dou f by dou x is equals to 0. That the formula of dou f by dou x, that is dou f by dou x plus lambda into dou pi by dou x is equals to 0. Now the partial differentiation of the dou f by dou x, that is we get 2x. Remaining variables will be 0, that becomes 0 values, plus lambda into partial differentiation of the phi, then we get 2x plus 3 lambda is equals to 0. Now 2x is equals to minus 3 lambda. Last we get x is equals to minus 3 lambda by 2, let it be equation 3. Now we go for the dou f by dou y. Then the partial differentiation of the dou f by dou y, that is 2y plus the plus lambda into dou f by dou y, that is we get 2. Now we get that 2y plus 2 lambda is equals to 0. Now 2y is equals to minus 2 lambda, then we get y is equals to minus lambda, let it be equation 4. At last we find the dou f by dou z, that is dou f by dou z plus lambda into dou f by dou z equals to 0. The partial differentiation of the dou f by dou z, that is 2z, remaining variables will be 0, plus lambda into dou f by dou y, that is 1 is equals to 0. We get 2z is equals to minus lambda, then z is equals to minus lambda by 2, let it be equation 5. Now substitute these x, y, z values in equation 2. From equation 2, that plane, that is 3x plus 2y plus z minus 12 equals to 0. Then substitute x, y this value from above equation. We get the 3 into minus 3 lambda by 2 plus 2 into minus lambda plus minus lambda by 2 minus 12. Then substitute in this equation. Last we get lambda is equals to minus 20 bar by 14. Then at last lambda is equals to minus 12 by 7. This is the lambda value. This lambda value substitute in above x, y, z values, we get real x, y, z values. From equation 3, 4, 5, we get x is equals to minus 3 lambda by 2. Now minus 3 lambda into 12 by 7. Now we get the x value 18 by 7. And also we find the y value. Y is equals to minus lambda. Y is equals to minus, then lambda value minus 12 by 7. We get the y is equals to 12 by 7. And also find the z value. Z is minus of minus 12 by 7 by 2. Then we get the z is equals to 6 by 7. These are the stationary points p x comma y comma z, that is 18 by 7, 12 by 7 and 6 by 7. This stationary point is on the plane which is nearest to the origin. Thank you.